Hey guys, in this video I'm going to go over parts of the Unit 3B review and go through 16 through 22. Alright, so in number 16, Philip has $300. He will spend $30 a day on food. He may spend money on other things as well, but will at least spend $30 each day on food. Create a graph and an inequality to describe how much money Philip, has at any given time. And number 18 should also say Philip. That's my bad. Typos. All right, so we need to come up with an inequality that somehow represents this situation. So you want to think about this. So we know that Philip starts with $300. Now we have three forms of equations. We have point slope, slope intercept, and standard form. So I'll go ahead and write down all three of those forms for us here. Okay. So we have three forms of equations here. Now we know Philip has $300, so he starts with $300. Well, usually the thing that we start with is also known as our y-intercept. So which of these equations, which of these forms gives us a y-intercept? This one. So if it's giving us a y-intercept, then we're going to want to set up our equation or inequality that way. I'm first going to set it up as an equation, even though they asked me for an inequality because it's a little easier that way, and then we'll find the inequality after. So we'll know we have y equals, well, he starts with $300. So I'm going to put down $300 because he has $300. But we also know that he's spending $30 a day on food. Well, that's going to be that he's spending $30. So out of the $300 he has, every single day that goes by, he's spending that. So it's going to be minus 30x. Okay. Now, we want an inequality, but we first have to figure out what our variables represent. Okay, so if we look at our slope is negative 30. Well, what does it represent? It means that he spends $30 a day on food. So $30 per day. $30 per day, which means that x is the number of days. So each day that goes by. Well, if you start off with $300 and you're spending $30 each day because x represents days, then what do you think y represents? Well, think about it. You start with $300, and every single day that goes by, you're spending $30. So the more that you spend, what's happening? You get less and less money, right? So you have money, and you spend it, and you keep spending it and spending it every single day. You have less money remaining. So your y is going to be the remaining money. That's what this means. Now, we know we don't want an equation. We need an inequality. So we need to come up with this. Now, y is our remaining money. Well, our remaining money can only be equal to 300 or less than that because we can't have more than what we started with, right? So y, our remaining money, is going to be less than or equal to the $300 we start with minus the $30 we take each day. All right, our next task here is to graph it. So let's go ahead and label our axes. So the x-axis is going to be the days, because we said the x variable is the days, and the y is the remaining money. Okay, well, for the remaining money, how much are you losing each day? Since you're losing 30 each day, let's go ahead and label our y-axis and go up by 30. So we'll start at 30, 60, 90, 120. So I'm going up by 30s because I know I'm going to be losing 30 and it'll help me graph it a lot easier. 180, 210, 240, 270, 300. And I'm going to stop at 300 because that's all the money that I have. And then for days, I'm going to go ahead and just label them, and I'm going to go by 1 because it's single days that go by. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay, so let's graph this. Well, it's in slope-intercept form, so we always start with our y-intercept. Our y-intercept here is 300, so, or 0, 300, right? So we're going to plot a point at 300. Well, what's my slope? My slope is negative 30 over 1. Negative 30 over 1. So we go down 30 on our graph. So we go down 30, remember 300 to 270 is 30, and then to the right 1, and we plot a point. So again, down 30 to the right 1, down 30 to the right 1. And we're going to keep going with that trend and go ahead and graph our entire graph here. Okay, Now, would this be a solid line or a dotted line? This would be a solid line because we have less than or equal to. Equal to makes it solid. But when I have inequalities, I also need to shade. Because this is less than, we shade below. Greater than, you shade above. So we'll go ahead and shade our entire side over here. Go ahead and color this all in. All right. So I've shaded it over there. All right, let's look at the next question. Philip found some headphones for $100. After how many days can he not purchase the headphones? So remember, on the y-axis here is our remaining money. So we want to look and see. So after 1 day, the most amount of money he can have is $270. So after 2 days, the most money he has is $240. After 3 days, the most amount of money he has is $210. So we want to keep going and see how many days until he can't purchase them. So we want to get to a point where he doesn't even have $100 and he can't purchase it. So let's test. After 6 days, he has $120. So he still has enough for headphones. After 7 days, he only has $90 left. So at this point, he can't afford those $100 headphones. So it would be 7 days. Because after 7 days, he only has $90. That's not enough to afford headphones. Okay, so we figured that out by just kind of looking to see where our graph was. So after 7 days, the most you could have, which is right here, is going to be 90. All right, the next question says, when will he run out of money for sure? So again, remember, this is your remaining money. Having zero money is being at the very bottom. So after how many days did it take? Well, if we look at our x-intercept, after 10 days, how much money does he have left? 0. So after how many days will it take for him to run out of money for sure? 10 days. All right, moving on. Number 20, the graph represents the inequality describing how much water could remain in a local water tower. Write an inequality that describes the graph. Okay, so they're asking us to write an inequality. Normally when we want to write inequalities, we want to do the slope-intercept form just because it's a lot easier for us. So we want to get it into y equals mx plus b, and it's also easier to graph. So in order to have an equation, we need at least 2 points. Well, I see that there are 2 points plotted on here already. This point right here is the y-intercept, and that's going to be the point 0, 12. Okay. Well, do we have any other points that they gave us? Yes, this point down here is the x-intercept, which is known as 9, 0. All right, so we're given 2 points. Well, I want it in slope-intercept form. I want y equals mx plus b. Well, in order to get that, I need the slope and the y-intercept. Well, right now I have the y-intercept, but I don't have the slope yet. So I need to find the slope. So the first thing I'm going to do is I'm going to find the slope by using my 2 points. So we have slope equals y2 minus y1 over x2 minus x1. This would be x1, y1, x2, y2. So 0 minus 12 divided by 9 minus 0. So this would be negative 12 over positive 9, which simplifies to negative 4 over 3. So our slope is negative 4 over 3. Well, do we know the y-intercept? Yes, it's 0, 12. So let's plug that into this equation here. So this would be y equals, what's the slope? Negative 4 over 3. And then we have the x. And then our y-intercept, which is positive 12. So again, all we had to find was the slope because they already gave us the y-intercept. If they didn't, then we would have to start in point slope and then get to slope-intercept. So this is the equation, but it wanted an inequality, right, because they're shading. So we got to get rid of those equal signs. Well, the shading here is it done above the line or below the line? So look at your line here. It's shading below the line. So if we shade below the line, what kind of inequality is that? It's going to be less than. And because you have a solid line here when you graph, it's also going to be equal to. So this is going to be y is less than or equal to the slope, negative 4 over 3, and then x plus 12, which is your y-intercept. All right, so how many gallons could there be after 4 days? So locate days on your graph. Your days is going to be your x-axis. So It says how much water could be in the water tower after 4 days. Well, this is where 4 is. So really, the max amount of water it could have is probably about 6-7 gallons. But could it have 0 gallons? Yes, because there's a point there. Could it have 2 gallons? Sure. 4 gallons? Why not? Anything located in the shaded area is a possibility for 4 days. You could either have 0 gallons. You can't have 12 gallons though, right? Because 12 gallons would be if there was a point here. And that's not a solution. Remember, solutions are in your shaded area. So after 4 days, we could say we could have 4,000 gallons. We could say that. There's lots of answers for this. Anything that's located in the shaded area along this line here. Anything there. So from about, it looks like it's about 7,000 gallons all the way to 0 gallons. Anywhere in between. Again, multiple answers for that one. All right, number 22. Could there be 5,000 gallons left after 7 days? So let's go ahead and look at 7 days. So 7 days is going to be about right here. Okay, and let's go ahead and look at our most possibility, or our biggest possibility. The most amount of gallons we could have is probably about 3, maybe 3.5, 2, right? That's the most amount of gallons that we can have. So could we have 5,000 gallons? Well, 5,000 gallons would be right here, about right here. And that's too high. So you can't have 5,000 gallons. The most you can really have is about maybe 3.5 or 3. So no, because after 7 days, there's only about 3.5 thousand gallons. All right, so those are those 2 graphing problems. Again, these are 2 problems that tend to give us trouble because they are more of a word problem, but it's just important to analyze the key information they gave you.